Fermentation in the Arctic was not a culinary trend. It was survival technology, developed over generations to preserve protein through months of winter when fresh hunting was impossible. Inuit fermentation methods included storing seal carcasses under intact blubber-covered skin, allowing controlled enzymatic and bacterial activity to transform raw protein into preserved food with a different nutritional profile than the fresh original. More recently, researchers examining traditionally dried and fermented Greenlandic meat products have found rich microbial diversity in these foods. Communities of beneficial bacteria that represent a form of probiotic intake that modern fermented food enthusiasts are only beginning to appreciate. What fermentation accomplished in the Arctic dietary context was multilayered. First, it extended the shelf life of high-value protein through microbial preservation in the absence of refrigeration. Second, bacterial action during fermentation converted some proteins to carbohydrates, providing a modest source of carbohydrate energy in a diet otherwise almost entirely devoid of plant-based sugars. Third, and perhaps most significantly from a modern health perspective, it introduced diverse microbial populations into the gut of people consuming these preserved foods. A gut microbiome shaped by regular fermented food consumption is structurally different, typically more diverse, than one developed on sterile, shelf-stable modern foods. The relationship between gut microbiome diversity and health outcomes is one of the most actively researched areas in contemporary nutrition science. Higher microbial diversity correlates with lower rates of inflammatory conditions, better metabolic outcomes, more robust immune responses, and even measurable effects on mental health through the gut-brain axis. Traditional fermented foods, whether Korean kimchi, European sauerkraut, South Asian dairy ferments, or Arctic preserved meat, appear to contribute meaningfully to this diversity in ways that commercial probiotic supplements, which deliver limited bacterial strains in limited quantities, cannot fully replicate. A pointed warning belongs here, particularly regarding Arctic-inspired fermented meat and fish preparations. Traditional fermentation methods were honed over thousands of years by people with intimate knowledge of the process, the specific microbial communities involved, and the environmental conditions that supported safe outcomes. Botulism is a genuine and historically documented risk in improperly fermented animal foods, and cases have been documented in Alaskan Native communities where traditional fermentation practices have changed without maintaining proper conditions. Modern attempts to replicate these methods without deep knowledge of the microbiology involved can go seriously wrong. The safer modern application draws on fermentation traditions that are better documented for home practitioners: lacto-fermented vegetables, fish sauce, gravlax, kefir, and natural yogurt. These carry the same microbial principles with considerably better established safety profiles. The Arctic fermentation story is valuable primarily as evidence that the human gut has long been shaped by microbially rich food, and that the sterile, pasteurized modern diet may be depriving the microbiome of inputs it evolved to expect.